Myself Saujanya, working as Associate Professor in Civil Engineering Department, SSIT. Today we will discuss about the topic hydration of cement, which is very important in concrete technology course. So before coming to the introduction, we all know concrete is made up of coarse aggregate, fine aggregate, cement, water and some admixtures. So when the coarse aggregate is placed, there will be an voids between coarse aggregates. The particles between one aggregate to another aggregate, there will be voids. These voids will be filled by fine aggregate, where the fine aggregate size is very small when compared to coarse aggregate. Then the fine aggregate voids will be covered by cement, and when cement is mixed with water, there will be production of cement paste, and this cement paste will hold all the other ingredients like coarse aggregates and fine aggregates. Okay, this together will form a solid mass which helps in gaining the strength of the concrete. So coming to introduction, cement is a hydraulic binder as it binds the other aggregates of the concrete. So it will react chemically with water to form a solid mass. This is an irreversible process, and hydration is responsible for strength development. What is hydration? So it is a chemical reaction between the cement and the water. Whenever the water is added to the cement, there will be an hydration process where the heat release will be there. So the heat will be liberated from the system, so it is designated as exothermic reaction, and it is irreversible process. When the water is added to cement, it will lose its strength. Even if it is made into powder form, it will not be having its original strength. So it is considered as irreversible process. It produces binding compound. When the water is added to cement, it will become hard mass and it will bind other components. The main components of cement are tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminoferrite. So it is also designated as, for tricalcium silicate, it is designated as alite, dicalcium silicate belite, tricalcium aluminate salite, tetracalcium aluminoferrite as phthalate. So it is also called as Box compounds. Formula for tricalcium silicate is 3CaOSiO2 and it is abbreviated as C3S. Dicalcium silicate formula is 2CaOSiO2 and it is abbreviated as C2S. Then tricalcium aluminate 3CaOAl2O3 and it is abbreviated as C3A. Last one is tetracalcium aluminoferrite. Formula is 4CaOAl2O3 Fe2O3 and it is designated as C4AF. So the major role of these compounds are C3S helps to gain early strength, C2S will give lateral strength, that may be after 1 year also, C3A it will give initial strength and it will set very quickly, and there will be large amount of heat releasing during the hydrolysis of this C3A. The last one is C4AF. It contributes very little for the strength gaining of the concrete. Here it will also set very quickly, but heat liberated by this C4AF is very small amount when compared to C3A. So these are the heat releasing quantities by different major compounds of the cement. C3S will release about 500 joule per gram, C2S 260 joule per gram, C3A 865 joule per gram, C4AF 420 joule per gram. Among all these major components, C3A will release lot of heat that is in the range of 865 joule per gram, and the lowest heat released will be by C2S, that is 260 joule per gram. So since the heat liberation from this C3A is very large, gypsum is added to the cement in order to control this heat of hydration. Box has given a equation for all these components, that is C3A, C2A, C3A and C4AF. So the formula is as follows. So you can note down this formula. Hydration reactions. When C3S and C2S combines with water, it will form CSH, that is calcium silicate hydrate and calcium hydroxide, and it is also released. This CSH gel is the main component which gives strength to the concrete. CSH gel, it is the main building material and it helps in binding of other aggregates and cement. It is amorphous in structure. It provides about 60 to 70% of strength, and it is very fine and porous. In the diagram you can see this white color portion. It is the formation of CSH and this is CH crystals. Calcium hydroxide is also the byproduct of hydration of cement. It is very weak and soluble. It is responsible for durability issues and it also reacts with pozzolan. Stages of hydration. So when the hydration of cement takes place, there are mainly initial reaction, dormant period, acceleration period, deacceleration period and steady state. So this is the graph related to the heat of hydration. It is also called as heat of hydration curve. So the first is the initial state or the initial reaction. It is also called as pre-induction period, where the cement will be in wet state. C3A and C3S will be formed in this reaction. This reaction will last for a few minutes. You can see that in the graph. Here the heat of hydration will be very large and hydrolysis process takes place due to the formation of C3A and C3S. The next is induction period, where the heat drops suddenly and the heat of hydration will also slow down. This is mainly due to the addition of gypsum to the cement, and this period will last for 1 or 4 hours. It mainly depends on the type of the cement and also the temperature. Here the cement will be in plastic state. Whatever we have to do, whether we have to mix the concrete, place the concrete or transport the concrete, that should be done in this induction period. Next one is the acceleratory period, that is this increasing curve. Again the heat of hydration will increase and hydrolysis process will also increase. Here in this period CSH gel will be formed. Initial and final setting of the cement will take place in this period, and also the maximum strength of the concrete will be gained in this acceleratory period. Next is declaratory period, where the releasing of heat will be decreased and also the hydrolysis process will also be decreased, because the unhydrated cement availability is very less in this period, because maximum of the cement will be hydrolysis will be taken place. So here the heat released will also be less. Next one is period of slow continued reaction. So that is the last step, where it may continue months or years together until there is availability of moisture. This period will continues and the strength gain in this period will be very minimal. So as I told, in the first phase there will be formation of C3S and C3A. In the second phase, it is also called as sleeping mode, where the heat released will be less when compared to first stage. In third stage, there will be a gaining of strength for the cement will be maximum. In fourth, silicon ions will be decreased. The formation of silicon ions will be very less in case of fourth phase. Next, in the diagram, the first diagram shows the unhydrated cement particle. Here we can see C3A, C3S and also C4AF. In the second diagram, there is gel formation and also ettringite is also formed. In diagram C, outer CSH gel is prepared, that is after 10 hours. After 18 hours in the diagram D, ettringite is formed. In E, after 1 to 3 days, there is formation of monosulfate. In the F diagram, we can see the inner CSH gel formation in this diagram. So let us recap the things which I have told in the graph. In the initial stage, there will be rapid reaction of C3A, higher heat will be released. That heat of hydration and rapid reaction of C3A can be controlled by the addition of gypsum. In the dormant period, so that is the second phase where low heat is produced, concrete remains in plastic stage. So it is suitable for mixing, transporting and placing. Third one is acceleration stage where maximum strength will be gained by the concrete. So there will be rapid formation of CSH gels. So factors affecting hydration: water cement ratio, temperature, fineness of cement, admixture and curing condition. Effect of water cement ratio. So lower the water cement ratio, the concrete will become dense. If the water cement ratio is more, then the more pores and the voids will be there. If the proper hydration should be taken place means then there should be proper water cement ratio. Effect of temperature. If the temperature is high and during extreme heat also, the hydration process will be faster, but there will be durability issues in the concrete. If there is low temperature, then the hydration reaction will be very slow. Importance of curing. If the curing is done properly, then the hydration process will be completed and it will be helpful in gaining the full strength, and also the durability of the concrete will be increased, and it also prevents shrinkage cracks. Hydration and strength development. Strength mainly depends on the degree of hydration. At 7 days, approximately 65% of the strength should be gained by the concrete. At 28 days, it should gain 90%. So like that it continues for years together, but after 28 days, the strength gain will be very less. Microstructure of hydrated cement. It is having CSH gel, calcium hydroxide, unhydrated cement, and also there will be some capillary pores in the microstructure of hydrated cement. Hydration in blended cement. So blended cement means the cement may be added with some fly ash, silica flume, GGBS, like that. So in case of fly ash, it reacts with CaOH and there will be addition formation of CSH gel, and it also improves durability. So hydration in case of mass concrete. Mass concrete is the term used where the concreting is done for the large span of the structural element like dams, bridges, or it may be foundation. So here excess heat is generated because large amount of cement is used for the construction of this mass concreting structures. So heat generation will be more. So the heat inside the concrete core will be more when compared to outer surface. The outer surface will be cooled soon because it will be in contact with air. It is exposed to air. So this creates a temperature difference between the core and the outer surface of the concrete. Thermal cracking risk. So due to this temperature difference between the inner core of the concrete and the outer surface, there is a risk of thermal cracking. So the heat inside the concrete will be more, so it tries to expand. The outer surface will be cooler, so it will contract. So since concrete is weak in tension, there will be a chance of getting tensile cracks. So it is also designated as thermal crack. So you can see in this diagram, the outer surface of the concrete will be under contraction because it is cool. The inner surface will be very hot, so it will tends to expand. Since concrete is weak in tension, there is a chance of getting thermal cracking. So this can be prevented by using low heat cement because the heat generated by the low heat cement will be less. The low heat cement or blended cement can be used, like PPC and pozzolana slag concrete can also be used. So these cements hydrate slowly and releases less heat. So it can also be controlled, that the temperature can be controlled by temperature control measures are adopted to avoid such cracking by pre-cooling ingredients, that is cold water can be used or chilled aggregates can be used for the construction. Post-cooling using embedded cooling pipes can also be adopted. So proper curing and insulation can be done. Placing of the concrete in the layer can be done instead of pouring it at once. So practical application, if the mix design is properly done with the proper proportion of coarse aggregate, fine aggregate, cement and water, then we can achieve complete hydration. So while doing the mix design, we have to select proper type of the cement depending upon the application where you are going to construct, what will be the temperature and the type of the structure, so that we can control the crack and also we can increase the durability. Summary. So hydration is a reaction of cement and water. CSH gel provides strength. Heat affects concrete performance. Curing ensures proper hydration. The strength of the concrete mainly depends on hydration degree. So numerical problem. So chemical composition of cement is given. Calculate the main cement compound values by using Bogue's formula. So these are the component values. They will be given in the question paper. Solution. So first you have to write formula for C3S. So the formula for C3S is as shown. You can write down that. In the next step, you just, in place of CaO, you just write down those values given in the question. So you will get C3S is equal to 61.486%. Similarly, C2S, write down the formula. So here in place of 3CaO SiO2, you can replace this with C3S. So the value which you got in the previous step, that you have to substitute here, and you will get C2S as 21.65%. Then write down formula for C3A. Substitute the values of Al2O3 and Fe2O3. So you will get C3A is equal to 3.218%. Similarly for C4AF, write down the formula and substitute the value of Fe2O3. You will get C4AF is equal to 8.512%. Thank you.